Hey guys, so welcome to our week 2 virtual section for language and social identity. This is just for those of you who didn't have section with me on Monday. Okay, so this is going to be a little bit shorter than a normal section since I won't be stopping to see if people have questions and all that. But basically what's on the agenda is first I'm going to talk about different types of data and different things we can do with those types of data. And then after that, we're going to go over some R basics just to get you guys kind of up and running. I'm going to talk about RStudio if you have that installed, but I'm also going to go over using the kind of the server-based implementation of R that you can just access through your web browser. Okay, so let's go ahead and get started. So one type of data that we've already talked about, this is all going to be a review of Jed's lecture last Friday. The first type is nominal data. It's also known as categorical data. And nominal is related to the English word name, and that's basically what this kind of data is. It's just names or labels. So we can find an example of nominal data in the Buchholz et al. Perceptual dialectology study that you guys read and wrote about in reading response 3. So in that study, they collected ethnicity data for all of the participants in the study, and that's an example of nominal data. It's just a collection of names or labels. Okay, the second type of data is ordinal data, and this is very similar to nominal data. It's almost the same thing, but there is an implicit ordering in the different, amongst the different levels of the data. So one example of ordinal data that we can think of is, imagine you are participating in a study where you are rating sentences. So you're given a sentence, and then you have to pick a rating for that sentence just based on how grammatical it seems to you. So if this is on a piece of paper, maybe there's a scale at the bottom: bad, okay, good, and perfect. And your job is to circle which one of these ratings corresponds to the sentence for you. So this is an example of ordinal data because there's an implicit ordering between these different labels here. Bad is worse than okay, which is worse than good, which is worse than perfect. Okay, and the third type of data is numerical data. Goes without saying, I think, that this is numbers. In some cases, you might be able to coerce ordinal data into numerical data. Sometimes we do this with actually this type of sentence rating study here. We will imagine the lowest rating as a 1, this as a 2, this as a 3, this as a 4. Usually our scales are a little bit bigger than this, like maybe 1 through 7. But we can sort of force this ordinal data into numerical data, and which allows us to get averages for certain conditions in our study, things like that. Okay, we can also classify data based on the role it plays in our study. So the first role is called dependent variable. This is the measure of interest in your study. So an example of dependent variable would be like in the sentence rating task that I was just talking about, the rating of the sentence would be the dependent variable. And then the other type is independent variable. This is some factor that you have reason to believe will impact your measure of interest, or the dependent variable. So if I'm doing a sentence rating study, and one of the types of information that I'm storing with each sentence that I've created that I want people to judge is whether or not I think it's grammatical or ungrammatical. You can think of that as an independent variable, and I have reason to believe it will impact the type of ratings people will give. A kind of subtype of an independent variable is called a moderator variable. This is just an independent variable, but it's one that interacts with a different independent variable in some way. So imagine I'm doing the same sentence rating study, and I've classified my sentences, my stimuli, based on whether I think they're grammatical or not. And I am also classifying them by a moderator variable, let's say just how long the sentences are. And if I believe that shorter ungrammatical sentences are going to be rated better than longer ungrammatical sentences, then this would be a moderator variable. It interacts with this grammaticality factor in a particular way. Let's talk now about different descriptive statistics that you can use to get an idea of what your data looks like. The first one we'll talk about is just counts, and along with that, proportions, which can be expressed as percentages. So you can use these descriptive statistics to describe all three of the types of data we talked about earlier. So nominal data, ordinal data, and numeric data. So an example of counts and proportions can be found in the Buchholz et al. Study. Again, they collected ethnicity data for all the respondents, and in the paper they got counts for each of the ethnicities and expressed the percentages for them also. So let's look at that real quick. Okay, so in Table 1b, they listed all the ethnicities or ethnicity categories. And in the first column here, we see the count, so the number of participants who reported this as their ethnicity, and then percentages on the right. So this is nominal data, and it can be described using counts and proportions or percentages. All right, another type of descriptive statistic, or three different types, are considered measures of central tendency. These help you kind of get an idea of where the center of your data lies. The first of these is mean, or average. Second is median, and mode is another one of these. And these can only be used to describe numeric data. And then the fourth one is called dispersion, and standard deviation is a measure of dispersion. This also only applies to numeric data. Okay, so measures of central tendency give you an idea of where the middle of your data is, if that makes sense. But dispersion tells you more about the distribution of your data. So I pulled this graphic from Wikipedia. Where'd it go? Okay, so these two different colors you can imagine as two different sets of data that were collected in two different studies, and the height here just reflects the amount of data within a particular range. And both of these different colors, the different sets of data, have an average of 100. So they have the same exact mean, but that mean kind of disguises the fact that the distribution of these two different data sets looks very different. So the red data set has a more narrow distribution, the values collected lie within a smaller range, and in the blue data set, the values collected lie in a much wider range. The red data has a standard deviation of 10. A lower standard deviation means that the values in the data set lie closer to the mean, and a higher standard deviation means that the values in the data set are more widely distributed, are further away from the mean. So now that we've talked about that stuff, let's move on to talk about R. R is a programming language that's designed specifically for applications in statistics. So you can kind of think of it as a really fancy calculator that you use on your computer. Okay, so before we start actually doing stuff in R, I'll just talk a little bit about some of the different methods you can use in R. So you can use all the basic arithmetic operators in R. So if you feed two numbers into R separated by the plus sign, you can add things together. You can do subtraction, you can do multiplication, using the star, the asterisk, and then the backslash, forward slash is division. You can get exponents using the caret symbol, so 2 squared would be this. So let's go ahead and actually start doing some of that stuff in R. Okay, so there are 2 different ways that you can use R or run R code. One way is by installing R and RStudio on your computer. So you can get RStudio at rstudio.com, go to download, and the version you'll want to choose is the free version. And then pick whichever thing here corresponds to your operating system. RStudio is basically just a really fancy editor for using R, and you'll also need to install R, the programming language, on your computer, which is at r-project.org. And here you'll see a link to download R. So once you're here, scroll down, find USA, and just pick one of these websites to download it from. This one's at Berkeley. And then click one of these buttons, download R for whichever operating system you have. This will only work if you have a computer running Mac OS or Windows or Linux or something like that. If you have a Chromebook, it won't work. Okay, so if you've installed RStudio and R, and you open up RStudio, you should see something that looks like this. And there are 2 different ways of running code in RStudio. You can type directly into the console. So if I want to use some of my arithmetic operators here, 12 times 10, I can type that in and push enter, and R will return a value to me based on the operation I wanted to compute. You can also type code in R scripts, which are just little text files. You can type as much as you want. And just typing on its own won't run any code at all. You can run a single line of code by doing Control-Enter, and it will run it in the console down here. Or you can run an entire script by clicking Source up here, or I think Control-Shift-Enter. Yeah, and it'll run all 3 of those lines. If you don't want to use RStudio or R on your computer, you can use it through the browser. So we had this set up for us on a server at UCSC. Go to labav.ucsc.edu. And once you're here, you will be able to log in using your username, UCSC username, and your blue password. And the way you can run R code here is by, so you shouldn't see any of this stuff. I'm just going to get rid of it for now. You should see something that looks like this. Go to New, and then click under Notebook, click R. It'll open up a new tab for you, and you can type in R code right here. And you can run it either by clicking Run up here, or you can do Control-Enter. So this looks a little bit different than RStudio. These are, I think, called code cells or something like that. Okay, so let's just do some quick examples of using the arithmetic operators. You can do addition, subtraction, multiplication, division. You can do exponents too, so 2 squared, 4. So all of these will work in any kind of R that you're using. If this was the only thing R could do, it wouldn't be very useful. One thing we can do that makes R more useful is that we can store values, any kind of value, in what's called a variable. And we do that using what's called an assignment operator. So say I want to take the number 32 and store it in a variable that I'm going to give a name. We do that with an arrow, a dash and greater than sign, where we type the value we want to store on one side and then the name on the other side. So I'm going to name 32 my number, my underscore number. So if I do this and I do Shift Enter, I don't get any output, and that's because R is just doing stuff behind the scenes. It's storing the number 32 with this name. You can actually reverse the direction of the assignment operator just using the less than sign instead of greater than sign. So my underscore number, and then make the arrow go the other way, and 32. And I can retrieve the value stored under this name just by typing in my number and enter or Shift Enter, and it outputs the number. So now would be a good time to talk about functions in R. So functions are operations that R does that you refer to using some kind of name. So the first function I'm going to talk about is called the concatenation function. And it basically just allows you to create a list of objects in R. Those objects could be numbers. So it's referred to by C, and the arguments to this function are just placed inside of parentheses. So if I'm going to just glue a whole bunch of numbers together, I'm going to put them inside these parentheses and separate them with commas. If I do Shift Enter here, R just outputs those numbers as a little list. So I'm going to copy and paste this. I can also store this list of numbers in a variable like I did earlier. So I'm going to call this number list. A variable can have any name. I'm going to do Enter, Shift Enter. Again, it looks like nothing happened because it's all happening behind the scenes. And if I type in number list and do Shift Enter again, I get that same list of numbers. So those numbers are now stored under this variable. Another function we can use is called print. This actually does exactly what we've been doing. If you put the name of a variable or any kind of object inside the print function, it will return it as the output of the function. This doesn't look super useful right now, but it might become useful to you later. Okay, so let's talk about some other functions that correspond to some of the descriptive statistics that we talked about earlier. So let's start with mean and median. So I have this list of numbers here. Say I want to get the mean of it. I'm going to use a function called mean. Arguments almost always go inside parentheses in R, and these numbers are still stored in the variable number list. So if I just put the name of those numbers that I've given to them, number list, inside mean, Shift Enter, then I'll get the average of those numbers. You can also put a series of numbers directly into the mean function, but you have to put them together with the concatenation function inside of the mean function. So 1, 2, 3, 4, 5, 6. If I do Shift Enter here, I'll get the mean of this series of numbers. Another function you can use is median. So I'm just going to get the median of my list of numbers here, and it's 53. So moving on, another useful thing you can do in R is if you think you know a function and you want to know what exactly it does, you can get R to tell you what it does by making a question mark and then typing in the name of the function without parentheses. So if I do that with median and then do Shift Enter, I get a description of the function. So usually it will tell you the different arguments the function can take and give you some examples of how to use it, among some other stuff. If you do this in RStudio, you get something similar. It just pops up in a different place over here. Another thing you should know is that you can type in comments into your R code, and these are bits of text that R will not try to interpret in any way, but you have to start them with the hash symbol. So usually this is used to describe what your code does. It's most helpful for complicated code. So I'm just writing here that I'm going to get the mean of my number list. Do mean of the number list. And if I do Shift Enter, all I get is the mean of my number list, the same one that was up here. And R didn't interpret this comment at all. So comments are always prefixed with the hash symbol. So eventually we're going to be working with data stored in CSV files, which are spreadsheet files basically. And R has a special function that can be used to read in spreadsheets. So I'm going to go ahead and close this little notebook that I had. So in the online interface that you guys have access to, there's going to be a share folder. And this is a folder where Jed and I will be able to upload certain files that we want you to reference. So here's a CSV file, a spreadsheet file, and I'm going to show you how to load this data into your R environment. So I'm going to go ahead and open my Untitled notebook again. So first we want to make sure that R knows where to find that file. R has what's called a working directory, so it has a folder that it's looking in by default for any kind of file that you want to read in to R. And to see where R is looking currently, we can use this function called getWD, get working directory, and it will it has the open and close parentheses, but don't put anything in it. And when you enter that function, it's going to tell you the current directory where it's looking. So the directory that each of you should see here is this stuff followed by your username, and that corresponds to the folder that the share folder is in and any notebooks you might have started and saved. So that data file is in this share folder here. So what I want to do is change R's working directory to make sure that it can pull that CSV file from the share folder. So I'm going to use a different function called set working directory. And I'm going to go ahead and type in everything that's here again, /home. Oh, this has to be in quotations, either single or double quotes. So /home, /Jovians, /JW Vinson, /share. So go ahead and type this, but replace my username with yours. I'm going to push Shift Enter, and it looks like nothing happened, but it's all happening in the background. If I do get working directory again, I now see that I'm in the share folder. So now R should be able to see this week1_data.csv file. The way you're going to read in this data is using a function called read.csv. You're going to put the name of the file in single or double quotes, week1_data.csv. And for this particular file, you're going to use headers equals true. These spaces next to the equal sign are not necessary, but they just can help make the code look a little cleaner. If we do this, then what's going to happen is, I get an error because this actually needs to be header equals true. I'm going to try that again. Make sure you do the comma outside of the single quote here. So these are two separate arguments to the read.csv function. All right, so what happens when I do Shift Enter here is the data gets just spit out in the console. This isn't super useful. I mean, it's useful if you want to look at certain parts of the data, but what will be really useful is if we store all this data in a variable. So let's name that variable my data. And I'm using the assignment operator here pointing to the variable, and then on the right side of the assignment operator, I'm going to do the same function that I had up there, read.csv, week1_data.csv, header equals true. So this header equals true argument just says that it tells R that the first line of the spreadsheet is the names for the columns. Okay, then when I do Shift Enter, R has now stored this in the my_data variable. So now that I've stored that data or named it with a variable, I can more easily refer to the data inside of the spreadsheet. So imagine this data is from an experiment that I ran. I should mention that this is fake data. It's data that Jed made up. Let's say I want to get the average age of all of my participants. So I guess the first step, I can just get a list of all the ages of the participants without seeing any of the other data if I want to, by referring to my variable, my data, and then, so I'm just interested in this age column here. I'm going to look at that by typing in my variable using a $sign. This means what I'm going to get is a single column of my spreadsheet here, and I'm just going to refer to the age column. If I do Shift Enter here, then I just get a list of all the ages. So if I want to get the average age of all of my participants, I can include the name of this column here inside of the mean function. My average age here is 26.7 years old. I can also get the median age, which is 27, pretty close to the mean. I can get the standard deviation by using a function called SD. Okay, so I should probably at this point show those of you who are using RStudio how to do some of the same stuff. So the main difference here is that you need to download the week 1 data CSV file and put it in whatever your working directory is. So let's go to the classroom page. So the week 1 CSV, or week 1 data.csv is in the classes Google Drive folder. So I'm going to look for it. Oh, here it is. I'm going to go ahead and download this. It's going to go into my downloads folder. I'm going to go ahead and copy this data into the folder I have for Jet's class. Just put it right here. And then in RStudio, I'm going to see what my working directory is by doing get wd, like I did on the website. You don't want to do Shift Enter when you're using the console in RStudio. That'll just give you a new line without running your code. Just hit Enter. So I'm right here. I'm going to change my working directory because that is not right. So this is kind of long. If you click Tab, you can get a list of folders here. Okay. So I'm going to hit Enter, and that is now my working directory. Oops. Now that I'm in the directory where I put the folder, I can read in that CSV file. I'm going to call it my data just like I did on the website, and use the read.csv function, week1_data. This is case sensitive, so make sure you're using uppercase or whatever the case of the file is. Header equals true. True has to be in all caps. Okay, I read it in RStudio. It'll show up as this list of things that are in your environment. And just like I did on the website, I can refer to the age column, and I get a list of all the different ages of my participants. I can get the average age. I can get the median. Etc. Okay, so moving back to the website. Okay, so the last thing I want to talk about is using packages in R. So packages are little bits of software that kind of extend the functionality of R. The way to call a package to let R know that you want to use it in your session is to use a function called library. So I want to let R know that I want to use a package called dplyr, D-P-L-Y-R, and it'll let me know it's calling in the package, blah, blah, blah. I also want to use a package called magrittr, M-A-G-R-I-T-T-R. Okay, and once you enter those, you can use new functions that come with those packages. If you're using this web browser-based implementation of R, you don't have to worry about installing packages, but if you are running RStudio, you may have to install certain packages that we want you to use. And installing packages is done with a separate function called install.packages. Let's say I want to install the package magrittr. I got to put it in quotes. I'm going to hit enter, and it's going to go to work installing it. You can also give it a list of packages you want to install. And these are going to be combined with the concatenation function that we talked about earlier. So imagine I didn't just install magrittr, and I want to install it again, and also install dplyr. It's going to install both of those, one after the other. And as soon as those packages are downloaded and installed by R, you can just immediately load them. So I'm going to load dplyr and magrittr. And they're loaded. Okay, moving back to the browser. So these packages extend the functionality of R a little bit. One function we'll use from the dplyr package is called summarize. So if we do the question mark and then summarize the information it gives us, will tell us that summarize is part of the dplyr package, and then it'll tell you a little bit about how to use it. Summary is a different function that is just part of R without any packages added. Summary can be used to get some basic information about a whole data set. And we'll talk about how to use the summarize function either later this week or sometime next week. Okay, one thing that the magrittr package allows us to do is just sort of write functions in a different way. So if I'm thinking about my age column in the my data spreadsheet, I'm gonna refer to it again like this. Just to show you again, this gets me the list of all the ages of my experiment participants. If I wanted to get the mean age of my participants before, I had to enclose this bit of text in the mean function like this. But magrittr allows us to write functions in a slightly more natural way. So my data $age. And with magrittr, I can do this, what's called a pipe. %, greater than sign, %, and then type in just mean here. And this, when I push enter, it gives me the same exact thing. So this just allows us to write functions in a way that's a little bit more natural to us. So that's all I'm going to show you guys for now. So you can close out this file if you want to save everything you've done. Well, first by giving the notebook a name, practice. And then you can just go to close and halt. There we go. If you're using RStudio, it's going to ask you if you want to save your R environment when you close it. So let's go to quit session. And so it's asking if you want to save your workspace to your working directory. I'm just going to do it. And then the next time I open RStudio, it's going to reopen it with in that same working directory. Okay, that's it. So see you guys later this week, hopefully.